In the previous video, we considered how to safely power up the rover, and it's moving now, as you can see from here. But I control this rover with the radio controller pocket, Radio Master Pocket, 2.4 gigahertz now, and it means that this is not autonomous, but we want our rover to be autonomous, and it means that on board must be presented the Raspberry Pi or some other computer as a companion computer. With the computer vision, it can follow the target, sending MavLink commands via USB port using the MavLink protocol. But in today's video, I am gonna consider another way how we can control our rover in guided mode, also in guided mode, using the laptop computer and MavLink protocol, sending MavLink commands with 3DR radio module, 3DR radio module. So we will add this component, and in case if the MavLink commands work in guided mode with 3DR and the rover can move the same way, it will be moving with the same MavLink commands sending from the Raspberry Pi. So this is the first way how we can check that in guided mode the rover can be managed by MavLink commands. To connect this FPV radio telemetry air module, I will use this 4 wires, RX-TX, VCC and ground, and I choose the R3 and T3 paths on SpeedyB F405 controller. So the R3 and T3 on your 3 are already soldered, as well as its red wire to 5 volt, and now I'm gonna complete it soldering the ground. So air module, SIG radio, FPV radio telemetry is connected to the SpeedyB 405 flight controller now, and I also decided to add here another component, which is the buzzer, and it has just only a few red and black wires, and I am gonna connect it to BZ plus and BZ minus on the flight controller. As always, I check the connections with the multimeter, and I already checked this ground and the 5 volts, and also RX and TX, as well as BZ plus and BZ minus here. So we are ready to connect here 2 new devices, and let's see what we have. You probably remember as I like this double-sided tape, and this buzzer will be fixed on rover with this double-sided tape. Now, yeah, like this. So 3D module also fixed on the rover. Before running this rover again, let's configure this 3DR module additionally here in Mission Planner. So connect it. Let's connect it in here. Connect. Set up mandatory hardware, serial ports, and we have our 3DR module Secretia on the port UART 3. So I'm gonna set up here 115,200 MavLink second protocol. So it's gonna work, I think, with this configuration. So let's go to the data, fail safe because of the radio, EKF3 active. Yeah. On 3DR radio we have this green color, so module is working, as well as our buzzer, which can buzz now, and I'm gonna check how it works actually. On the computer side we have this FPV radio telemetry ground module, and I'm gonna put it instead of USB port to USB and here in Mission Planner we have this and this USB 0, so the baud rate will be 57, and let's connect it to the mission. Let's connect Mission Planner to the rover, to our rover, for telemetry data and control. So as you can see here, our rover is disarmed, and message we just received that RC out brushed PVM rover. And let's arm this. We armed. Buzzer signaled us that we armed. So, and in the Mission Planner interface we also have all the necessary information. So without any USB port, USB cable, we have connected to the rover with this telemetry module, and can receive telemetry and telemetry data and control the rover from the computer. So what do we have in here? Our mission planner is connected via the ground module, the 3DR radio to the rover. Now also with the radio controller I can arm and disarm this, like in here you can see, and this is armed, and with this button, the same button, I can disarm. For now I am gonna show you how we can disarm, arm, and make any other commands with the MavLink protocol. So in here I have this small Python code which uses MavUtil from MavLink library, and the first command in here is establishing connection with the same DFTTI USB 0, which we use for telemetry in our mission planner, and the same baud rate. We will use this to connect and to execute the command long send, which named as MavCMD component arm disarm. In here the value, if we want to arm, must be 1, if we want to disarm, must be 0. So I am gonna disarm it, I will arm this with the radio controller, but disarm with the script, with the Python script. So here I push the arm button, and as you can see in mission planner, it's armed now, throttle armed, and with this script I am gonna disarm this. So I press enter, and as you can see, heartbeat okay, disarm command sent, and we can see in mission planner that it was disarmed. So MavLink command was executed, and now the rover is disarmed. Besides of the button, which is in arm position, but I can't control the rover with the throttle now, because it's disarmed. So it's the simple Python code which we just executed, and this is how we are going to make this rover autonomous. The major idea is in that with the computer vision module we will see the target with the special algorithm, target following algorithm. We will calculate where we have to move our rover, and with the other MavLink commands, not with this but with another, we will send the MavLink commands to the rover, and it will move the rover. And in this task, the main challenge is in moving the rover with MavLink commands, because the ArduPilot firmware requires different sensors and a lot of different conditions must be positive to make it moving in guided mode. So I am gonna consider this moving with the Python program in the following video.